Hello and welcome to Maths with Jacob. This lesson will focus on enlargement. Enlargement involves taking an original object or shape and increasing it in size. We need a point called the center of enlargement. Also, we need a scale factor that tells us how much an object is enlarged. Let's look at two simple examples. If that point there is called the center of enlargement, and we have an original triangle here, let's see that triangle there. Now, if we wish to have an image that is twice as large, that is, each side is twice as large as the original, all we do, we take those lines out, there, through that point, and from there through that point. Now, we measure the distance from there to there, and then we make that distance twice as large. That's 2D. So whatever that distance is, the distance from there to there is 2D. Whatever that distance is there, that distance is twice as large. And whatever that distance is to that point there, the distance from there to there is twice as large. So in other words, here's our image. It's been enlarged, and each side is twice as large as the original. So the distance from the center of enlargement to the large triangle is twice the distance from the center of enlargement to the small triangle. So the scale factor is 2. So that's basically what that's about. The scale factor is 2 means that the sides of this one are twice as large as the sides for this one. This shape here, exactly the same idea. If that's the center of enlargement, and we take all these green lines out, all the way out, okay, through each of those points, so all these little end points here, just take the lines all the way out. If you have a scale factor of 4, that is, whatever that distance is there, then the distance from there to there is 4 times. And it's the same for every point, and then you join those points up, and then from there to there is 4 times the distance from there to there, and so on. Let's look at some examples in real life. Here we have a little model. Let's say that's the original. And here we have the enlargement. That could be the real vehicle. Now, this idea here is a great way to find, for example, the height of large trees. So say, for example, you have a large tree here, and all you do is you pick a point on the ground, that point there, you measure the distance to the tree, and you have a look through there. That's like a line of sight, if you like. And then you get a stick, and you make sure that that stick goes up. It doesn't have to be too large. And it's equal with the line of sight. So when you look from there, you see the top of the stick, and then you see the top of the tree. So that could be the original there. That one there is the image. And you will see later on that with a very simple mathematical approach, using what we call similar triangles, you can actually find the height of that tree. Now the idea is, we have the center of enlargement, we have the original image, which is the little stick, and that can represent the enlargement, if you like, and that whole idea enables us to find the height of the tree. Here, we've seen this so often in cinemas or picture theatres. The small image is here, that is, the original image is inside the machine, and then when you project the image onto the screen, it becomes a lot larger. And here are 3 examples of coffee cups, for example. Small, medium and large. See how they've been enlarged as we go across. And you could have a sort of a center of enlargement. It could be out here somewhere. Right, so the center of enlargement might be here, And then you've got your little rays. You know, the lines that go through that we saw earlier, they could go from there, for example. This is only very rough, or they could go from there. So it's exactly the same idea. So this video has introduced us to the basic idea of enlargement, and we've seen some examples in real life.